Our class, hey, this is the video for the practice test, the STAAR practice test. So if you were not here on Friday, I highly recommend that you try this practice test before you take the STAAR test. Okay? And so to log on to the practice test, go to the Canvas page, 429 module on the Canvas. Click on the link, and you're going to come to this page right here. Scroll down to the bottom and hit practice test login. And from here, don't mess with the guest user and guest session. Just hit sign in. And of course, select the grade level, which is 9. And then from here, I want you to, you're going to hit the link for the Start 2021 STAAR Algebra 1 new item types, right? That one right there. Here, it allows you to mess around with the different features, such as the color setting, if you want a large mouse and all the good stuff. If you want to play around with that, you can. If not, just hit select at the bottom. And then from there, again, you can look at your settings. And then if not, just begin test now, okay? And so the first question is number 1, and it asks you, it gives you an expression, and it wants to simplify it. And of course, that's exponents. And so what I'm going to do, I cannot write on this window right here. So I'm going to go back and forth between the smart file. So you want to simplify this expression. I'm going to write this a little bit bigger. So we have x to the 6. Oops. We have x to the 6, y z to the 7th over x and y squared and z squared. Looks like z squared. Okay, so the first thing you want to do, guys, is make sure everything has an exponent. Again, make sure everything has an exponent. So that doesn't have 1 and the y doesn't have 1. Now, remember, when we divide with exponents, we subtract them, right? And so I like to work in columns, just to make sure I'm doing this correctly. So for the x's, I'm going to have x, 6 minus 1 is 5. For the y, 1 minus 2 is -1. And for the z, is 7 minus 2, which is 5. Now, remember, we don't want a negative exponent. And so this one, we're going to slide the y to the bottom to make the exponent positive, okay? So we're going to have x to the 5. We're going to have x to the 5. Come on. X to the 5. Z to the 5th power. And then we're going to slide the y to the bottom to make the exponent positive. All right, so that's your answer right there. Now, how do you enter this in the STAAR practice test? Now, my answer is in a fraction format, right? So what I'm going to do is, if you notice here at the bottom, and for some reason, can I make this a little bit smaller view? What is this? 90 still. Okay, I'm trying to make this. At the bottom right here is my fraction tab, I guess. If I click on it, okay, it gives me where I can enter my answer as a fraction. And so it is x to the 5th, right? So I'm going to have x, and then I'm going to click this one here, this icon, or this tab, to give me, so I can enter the exponent of 5. Why it keeps on doing this, I'm not sure. And now, if you notice now, the cursor is next to the 5. If I continue, if I put my z, look what happens here. My z is my z. trying to find my Z. Okay, let me pause for a second. I've got to fix this. All right, I'm back, guys. And so we have X. So I'm trying to get the cursor. Come on, come on. All right, this is a pain doing it right here. Come on. I cannot get it. Nope, that's not what I want. That's not what I want. That's not what I want. Okay. This is not working. Okay. All right. I need to get it down. Okay. Ooh, Z to the 5th. Z again. I'm going to use this button right here. All right. You can't see, but use this one to give me the exponent of 5. And then at the bottom is Y. Okay. Well, that was a tough one to get done. All right. Okay. So that's the answer for that one. So remember, also remember the rules for working with exponents. Okay. Let's go back real quick here. So remember the rules. And again, these are all in videos from other classes. Okay. You know, when you multiply, say, 2x cubed times, let's put a parentheses, times, say, 4x squared, all right? You multiply the coefficient, 2 times 4 is 8, but then you add the exponent, 3 and 2 is 5. All right, and also if you look at, again, I want you guys to become familiar with the reference chart. Again, if you're stuck, if you don't remember what the rules are, click on the reference chart on your STAAR. Right, it gives you the rules. Okay. And so if you look at exponents, it tells you here, when you multiply right here, AM times a to the n, you just add the exponent. So it gives you the rules. So just make sure if you get stuck, you can follow them right there. All right. Okay, and number 2, here, and number 2, it asks you to write the equation in standard form. You can tell now this is, if you look at it, this is a quadratic function. So you're going to ask, what standard form are they asking for? Well, it is this equation here, x plus 4 squared, is a quadratic. So therefore, they're looking for, again, go back to my references. All right. If I want to go to, that's the linear equation, no, quadratic equation, it is ax squared plus bx plus c is a standard form. Okay. So if you don't remember that, so let's go back to my slide here. Let's go back. One more, okay? So I want to write this in ax squared plus bx plus c. But how do I do that? If you notice now, I have an x plus 4 squared. I have to expand that. And how do you expand that? Well, remember, x plus 4 squared is just x plus 4 times x plus 4. And if I'm multiplying 2 binomials, right? Some of you guys know how to do this by distribution, right? You can take, you know, the x times x, x times 4, and then 4 times x, 4 times 4. Some of you guys can do that. If that doesn't ring a bell, use the X box method. Okay. X goes there, 4 goes there, x goes there, 4 goes there. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And some of you guys are putting 8 here. Remember, you don't add the 4s, you multiply them. Gives you 16. And so when I add all the terms inside here, this is my first term, that is x squared. This is my last term, it goes to the n. And then I'm going to add these two. 4 and 4 is 8. X. Some of you guys are putting square there. No, 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 you can't do that. You just add, it gives you 8x plus 16. But no, I'm not done. This is a minus 18. I got a minus 18 there. So now I get x squared plus 8x, 16 minus 18 is minus 2. So that is in standard form now. All right. And so if I go back to my, so I'm going to enter this now. It's going to be 8x, I'm sorry, not 8x. What was it again? X squared, right? Yeah. X, and then the square. I think there's another one you can use. Where's that? I don't see here. Okay, it'll be X. Okay, I'm going to use this one. Square. Okay, and then it was plus 8x plus 8x minus 2. I think that was the answer. Minus 2, minus 2, minus 2, backspace, backspace. Where's that? Backspace. 2. Let me double check on that one. That was, yes, 8x squared plus 8x minus 2. Yes. So that was the answer. And so I just move on to the next one. All right. Okay, which value of m? Which value of m satisfy the equation? All they're asking you to is solve for m. That's all they're asking for. And so in class today, I asked, how do you solve that? And some of you guys were like, oh, I don't know. Remember, if you don't know to do this if you can't do this algebraically, all right, I've showed you guys, I'll do this on a calculator. Menu 3-1. Okay, some of you guys forgot that. All right, if not, some of you guys can do this. Let's do by distribution first. All right, 6 times 4, that's going to be 24m. 6 times negative 3 is minus 18, plus 6 is equal to 4 times 4 is 16m, and 4 times 11 is 44. Okay, these two terms I can combine together, so that gives me 24m minus 12, is that correct? Yes, minus 12 is equal to 16m plus 44. I'm solving for m, so I'm just going to cancel this 16m right here. Okay, so now that gives me 6 and 4, that's giving me 8m minus 12 is equal to 44. I'm going to cancel the 12 now, plus 12 plus 12. Okay, that becomes 0. Now I'm left with 8m. Left with 8m is equal to 52. Oh, I'm sorry, 56. What is m equal to? M is equal to 7. Okay, that's one way of doing it. Or you can go to your calculator, menu. Where's my calculator? Okay, you can go home, new. No, I don't want to save that. Calculator and press menu 3-1. I enter the equation into end solve. I'm not going to do that. Just remember at the end, right? At the end, when you use menu 3-1, okay, you have the parentheses. At the end, you got to put comma m at the last. All right, guys. Okay. So that was answer. Answer was 7. Answer was 7 on this one. Put 7 right there, and go to the next one. Okay. Let me pause for a second. I've got a text coming in. All right, I'm back. Okay, so on number 4, it asks you to find the rate of change. Okay, again, anytime you guys can pause video and work on it. Rate of change. So my rate of change is, again, let me go to my slide here. Next. So remember, rate of change, right, is just the slope. That's all they're looking for. And so delta y over delta x. So remember, the cost is going to be your y's. The square feet purchased is going to be x. because the cost depends on how many feet you purchase. All right, so this is dependent. So you take a delta y, which is going to be, say, y2 minus y1 over x2 minus x1. And that's going to give me 980 minus 840 over 140 minus 120. And that gives me 140 on top and 20 on the bottom, and that just equal to 7. All right, so my rate of change is 7 square feet. And so if I go back here, I'm going to enter 7 here, and I'm good to go. Move on to the next one. All right. Okay, now this one, again, it's going to test your knowledge of, okay, before I move on. Again, guys, when I ask you what kind of function is this, some of you guys struggle on it. You're telling me it's linear. It's quadratic. You got to know this function, what it look like. And if you're still stuck, again, go back to the reference chart. All right. Okay, you know linear is just y equals mx plus b, or y minus y1, or our standard form is ax plus by equals c. That's linear. Quadratic is x squared. So you can use your reference chart to help you. All right, you know it's not linear, you know it's not quadratic, so it has to be exponential. All right, so I'm going to click on exponential. That's my graph right there. But is the graph in the right place? All right. Now, two ways you can do this. Some of you guys probably going to graph this right here, all right, on a calculator, and then make sure it matches. Make sure the graph on the STAAR matches it. In fact, let's do that, because most of you guys are going to do that. So I'm going to graph this in my calculator. Okay. And so let's go to my calculator. Since you guys probably going to use the one on the yellow calculator, right? So let me go to that one. So it's 6. Okay. Ohm, new. I want to graph. Graph. So I think it is what? It was 6. I believe it was 6 parentheses, 2 divided by 3 close parentheses, and I think I know it has to be exponential. So it's x. All right. That's the function right there. And so I'm going to enter. Now that's what it looks like. So it's decreasing. And now you notice now, right, that the line crosses the y-axis at 6. That's my y-intercept. So before I can go back now and look at, so this is going the wrong direction. So I'm going to flip it now. The line, the y-intercept is 6. So I'm going to put one of these dots on 6 right here, okay? And you can tell also by looking here, in the graph, 6 is the y-intercepts. Now, this second point right here has to be in the right location. If not, they're not going to, if it's not in the right location, they're not going to give you credit for it. They're going to take points away. So how do we know this is in the right location? Well, go back to where you graph it now. You got to make sure, go back to where you graph it. Let's press table. Let's see all the points. Control T, T, where's T? Okay. So these are all my points. So I can see, I look at it now, I see when x is 5, right? When x is 5, am I on the right ones? Is it 6 to? Okay. When x is 4, we have 1.1, or we can say roughly 1. And when x is 6, let's go with when x is 4, we have 1.1, right? When x is 4. So I'm going to place the second dot at this point. 4, 1.1. I'll just call it 1.2. Let's see. Let's go back over here. So that's how we're going to place that second point. Back to my, so when x is 4, right, it is roughly 1.1. When x is 4, 4, you know, just if you put it on when x is 4, yeah, right there. That's 2. 1.1. Come on. All right, well, right there. All right. Are there any other better points I can use? Let's see. When I go, let's scroll up. Oh, look at this one. When x is 1, y is 4. All right. Maybe that's a good one to use. When x is 1, I can use it as a second one, as my point. Let's go back to it again. When x is 1, I can say when x is 1, y is 4. So that's my, there you go. All right, so that second point, the points have to be in the right location, else that will not give you credit for it. Okay, so that's how I use graphing to help me. Let's move on. This one, again, if you look at it now, in class I asked, you know, what kind of graph is this? By looking at the word problem, and folks are giving me linear. All right, remember it can't. Let's go back over here. Okay, again, now that's this one here. All right, we have f of x is equal to x squared. That's given in the word problem. That's not linear, guys. All right, if you're not sure, check the reference sheet. That is quadratic. All right, so we're gonna hit a quadratic right there. All right, so let's go back and look at this now. So we know it's gonna be quadratic, okay? And no, so if you know, this is a transformation because it says it was transformed to create a new graph, g of x. It was transformed. And the transformation here is minus f of x minus 3. That looks kind of confusing to you, right? Well, just take it step by step. You know it was transformed, so, and the minus sign tells you the graph got flipped. So let's flip the graph, all right? I flip the graph now. Now, what's the next transformation? We have x minus 3. Well, remember in transformation, again, all this is in videos. All right, if we have f of x is equal to x minus 3 square, right? The x minus 3 tells you the graph went to the right 3 units. All right, if this was a plus, then it went to the left 3 units. You got to remember those stuff. All right, and so let's go back here now. So x minus 3, that the graph shift 3 units to the right. So I'm going to move this 3 units to the right. That's 1, 2, and you got to play around with this to move it 3. Okay. Now the plus 4 just tells you that the graph moved up 4 units. So remember, the graph was at origin. It was right here, so it got moved. It got moved up 4 units from the origin. All right. So the vertex now is 4, 3. That's the vertex right there. But this second dot right, this second point, is it in the right location? That's, we gotta be careful now. So let's see now. Let's look at, we're gonna graph this new transformation, see what it looks like to help us. All right, there's another way you can do it, but I'm just gonna graph it. So let's look at the transformation. So the transformation is f minus, okay, the transformation is minus x minus 3. So we're gonna have x minus 3 squared, all right, and then the plus 4. All right, so let's graph this now, f of x. I'm just going to graph this part here in the calculator, and then I want to find a good point that I can put that second dot on. All right, so let's go back to my calculator. Okay, graph, home, let's press home, new, no, graph. So it's going to be minus parentheses x minus 3 close parentheses, all right? And that square shift 2, and then make sure my cursor is down, plus 4. All right. enter. Again, the reason why I'm doing this, I want to find that second point on that second dot. I want to be in the right location. So I'm just going to press Control T. I want to find a good Control T. Let's see. We can try. Let's look at it. Go back and look at the graph here. All right. Let's see if I put it on the x-axis 5. Let's see where when x is 5. Let's see where that graph is. Right, when x is 5. Let's see. Go back and look at it. Okay, so we have so we could use all these right here. When x is 4, y is 3. When x is 5, y is 0. So we can use, those are two good points we can use, right? Let's go back and look at this now. So when x is 5, we know y is 0. I could use that one, 5, 0, or I think it said when x is 4 is 3. Is that what it says? When x is 3 is 4, y is 4. We could use this one. Oops, not that one. We could use when x is 3, right? When x is 3, we could use 1, 2, 3. When x is 3, is that correct? Did I read it correctly? X minus, why is it not giving me that? Give me a second, I think I want to make sure. Oh, when x is 4, I had it backwards. When x is 4, y is 3. I had it backwards. When x is 4, right, y is 3. Okay, right there. So I can use this one, 4, 3, or 5, 0. Either one. But you got to make sure you pick the right points. All right, good. And that's it right there. Let's go on to the next one. Let's see. Okay. All right. Again, quadratic function. It tells you here quadratic function, and it says graph the line of symmetry. All right. So the axis symmetry. It wants the axis symmetry. Now, if you look at it, guys. Okay. They give you 3 dots in the graph. They tell you it's a quadratic function, right? So you know a quadratic, it looks like this, for instance. All right, they give you 2 dots that are on the same line. So you know that's where the graph's going to pass through. So here they give you 2 dots right here. So you know the graph's going to look like this, right? And my drawing is not going to be great, right? They're telling you it looks something like this. All right. And you know now the axis symmetry is going to split the graph in half. All right, it's going to split the graph in half. So the distance between these 2 points is going to split it in half. All right, that's all they're saying. So if you look at it now, this dot is on 0, this is on -4. Halfway in between is -2. That's all they're looking for. So that's where the axis of symmetry is. And so if I go back to my graph now, right, it's going to split it's the line, the axis of symmetry is going to cross the x-axis at -2. So if I put a dot there, I got to put 2 dots to get a line, right? It could be there, or just as long as they're in that same on the same line, vertical line, it gives you that straight line right there. And that's it. That's the axis of symmetry, x equals 2. Okay. Here, you're asked to graph the equation. Remember now, we can't graph this equation in a calculator because it's not in the form of slope-intercept form, y equals mx plus b. You got to transform that equation. So here we go. All right. So we have 3x. We have 3x minus 5y is equal to 15. You've got to convert this equation to y equals mx plus b if you want to graph it. Well, there are other ways you can graph it, right? But let's keep it simple. Convert it to y equals mx plus b. All right. And to do that, if you notice again, I'm going to minus 3x here, minus 3x on this side. All right. That goes away. Now I'm left with minus 5y is equal to minus 3x plus 15. And then I divide both sides by -5, -5, -5, -5. That gives me y is equal to 3/5x minus 3. Now it is in slope-intercept form. My y-intercept is -3, and my slope, all right? So B is my -3. That's my starting point of graph. So I'm going to start right here in the graph. And my slope is m is equal to 3/5. What does that mean? That means I'm going to go up 3 units and to the right 5. And that's going to give my second point. All right. Another way some of you guys can do this, all right, is find the x and y intercept. All right. All right. Another way you guys can do this. Okay, before I start though. So before I start the second way of doing it. So my starting point is going to be -3 right here. I'm going to go up 3, 1, 2, 3, and I cross 5. So those are my 2 points. All right. You do that on the STAAR, the next window, it'll give you the line. All right. Let me back it for a second now. In fact, let me do this real quick and come back. So let's go back here. So I'm going to do this now. So my starting point is -3. I go up 3 and over 5. That's my second. That's my line right there. All right. Now, the other way I was trying to tell us, I was saying you guys could do this. And some of you guys can probably handle this. The equation is in standard form. It is in standard form, right? This is my A, that's my B, and that's my C. So if you remember when we did this some time ago, the x-intercept, this is only what is in standard form. X-intercept, right, is it's going to be C over A. C over A, and the y-intercept is C over B. So C over A is just going to be 15 divided by 3, which is 5. That's my x-intercept. The y-intercept now is C over B, which is 15 over -5, right? Which is -3. So now let me erase this now and get some space. All right. All right. So we know the x-intercept, right? The x-intercept, let's say x-intercept is 5, and the y-intercept is -3. All you got to do now is, again, look at that. All you got to do is -3 and 5, and it gets you the line. All right, so a different way of doing it. But if you're not comfortable with the x-intercept and the y-intercept, transform it to y equals mx plus b. All right. Again, this on the x-intercept C over A, and the y C over B only applies when it's in this format. All right, just make sure you understand that. All right, let's look at the next one. I spent a lot of time on that one. Where we're at, number 9. Ooh, got more to go. All right, let's look at this one. Again, it's asking you to write the solution set. To write a solution set, you got to graph these lines. All right, and where, okay, the first line is, let me go back over here. Okay, so the first line, how many, it got cut off. What is it again? Y minus 3 for x plus 4. Let's see, minus 3 for x plus 4. Minus, so we have -3 for x plus 4, and that is y is greater than, that's 1, and the other one is 3 over 2 x minus 5, 3 over 2 x minus 5, 3 over 2, come on, 3 over 2 x minus 5, and that's y is less than. All right. Okay, so we're gonna graph this. How do we graph this, guys? Remember, when we're gonna use rise of a run. We're gonna use the y-intercept as my starting point. So for the first equation, right, my y-intercept is gonna be 4, which is right there. And then my rise, for the first equation, my rise of run is gonna be, I'm gonna go up, no, I'm sorry, I'm going down because it's -3. I'm going down 3 and to the right 4. Okay, so down 3, 1, 2, 3, and over 4, which is going to put me right there. So that's going to give me my first line. I'm going to shoot on the star, but it's a dashed line, right? Boom, 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 boom. And it's greater than. So my shaded area is going to be, because greater is above the line, my shaded area is going to be this way. Okay. Let's go to the second line now. My starting point is -5. Right, so that's my starting point. -5 is, it's a different color. -5 is right there. And my slope is not, I'm going up 3. I'm going up 3 and to the right 2. So up 3, 1, 2, 3, and to the right 2, 1, 2. So that's my second. And so it's going to be, again, a dashed line, right? Dashed line. And now it's less than. So everything below the line, less than is this side. So we shade, and you can see this is where the area intersect. It's going to be my solution area. So let's go back and look at this now. So here we go. So you got to select graph. First graph, the line is going to be a dashed line. And my starting point for the first one again is going to be 4. All right. And down 3, is it down 3 and across 4? 1, 2, 3 and across 4. That's my line. Okay. Again, second line now. Second graph, you got to make sure to get highlighted. I'm going to start at -5. And I went up what? I go up 3 and across 2. Up 3, 1, 2, 3 across 2 is right there. Ooh, this should be a dashed line. All right. And then once you're going to select the solution set now, the solution set is just going to be right there. All right. Good. All right. Let's move on now. Here, it asks you to graph. The solution set. Again, when this inequality, again, for inequality, you want to make sure you transform the equation to y equals mx plus b. You got to make sure you do that, else you run into trouble. So let's go back to my slides. All right, okay. So we have 5x plus 6y is less than or equal to 30. Again, when it's inequality, you want to transform it to slope-intercept form. That's what you want to do first. All right, don't assume in this case, going to work fine, but don't assume, that the sign is always going to be less than or equal to. It may not be. Okay, so that's why you got to transform it. Right, so let's do that now. Okay, minus 5x there. That goes away. So now I'm left with 6y is less than or equal to minus 5x plus 30. Divide both sides by 6. Divide by 6. Divide by 6. Divide by 6. Y is less than or equal to -5 over 6x plus 5. So my starting point B is 5. That's my starting point. And my rise and run is I'm going to go down 5 and to the right 6. All right, let's do that. So down 5 to the right, down 5 to the right 6. Can I remember? To the right 6. Down 5, down. So we said it was -5, right? What was it? Oh man, I can't remember. What was it again? Oh, starting point is 5. Okay, almost mixed that up. Starting point is 5, and we go down 5 and to the right 6, to the right 6, down 5 is at origin, to the right 6. Oh, I didn't pick my line, right? It's less, okay, the line is solid, yes, solid. And then down 5 to the right 6. That's it right there. And now the solution set, right? Because it's y, because it is y. When we solve it, we got y is less than or equal to, right? So therefore, we're going to shade below the line. We're going to shade below the line. So everything below the line, we're going to, oops, nuts. Oh, I didn't pick solution set. Got to do that first, and then you hit there. All right, below the line. Good. All right. Okay. Some of you guys were like, number line. Oh, the Simpson number line. Guys, just read the problem and see what it's asking for. It says use number line to help you represent the solution. All right. So the number line is helping you. Well, but to use number line, you gotta solve for J first. All right. So let's go back over here now. We gotta solve for J. Come on. All right. We're gonna solve for J and all right. Here we go. So let's rewrite this a little bit bigger so you guys can see this. So we have minus 3, 2j minus 11 greater than or equal to 8j minus 9. All right. So we're going to solve for this. Well, unfortunately, you can't use the calculator for this one, menu 3-1. You can't use it. You got to solve it algebraically. So we're going to distribute now. So that gives me minus 6j plus 33 is greater than or equal to 8j minus 9. Okay, I'm going to move my j to the right side. So I'm going to minus 8j minus 8j. Okay, that gives me 14j plus 33 is greater than or equal to minus 9. I'm going to minus 33 now. Oh, this is minus 14j. Got it, careful. Minus 33 on both sides. So that's going to give me, that becomes 0. Gives me minus 14j is greater than or equal to, did I make a mistake somewhere? Oh, minus 9. Let's see. Did I make a mistake? Minus 8. Okay, minus 6. Yeah, that's right. Minus 8 on both sides. That gives me 14. And then plus 33 minus 33 on both sides. 18. Somehow I think I'm making a mistake. Okay. I'm tired. I think this is driving me crazy. All right. So add 33 on both sides. All right. Minus 33 on both sides. That's going to give me 2 9s 18. Carry 1. 48. Yeah, I'm making a mistake somewhere. Because 2. Yeah. Hold on, guys. I am not seeing my mistake here. Hold on a second. All right, I see my mistake. This should be a 3 here. I'm getting tired. All right. Let's see. So that's going to give me 42. Oops, that's not what I meant to do. That gives me a 42. Okay. Now, this is where you got to be careful, all right, when it comes to inequality. Here, I'm divided by a negative number. When I do that, the sign's going to flip. So divide by negative 14, divide by, this is negative 42, right? Yeah, negative 42. Divide by negative 14, this becomes now, right, J, right, is less than or equal to, right, less than or equal to 3. The 3, yes. All right. So you got to be careful because if divided by a negative number, the sign is going to flip. Sign is going to flip. So now let's go back to the inequality sign. This is where the number line. That's where everybody was like, oh, Mr. Simpson, number line. So J is less than or equal to 3. Now, remember, because it's also, oh, I forgot to do this. Because it's less than or equal to, I'm going to use a closed circle. So remember, less than or equal to, greater than or equal to, you have a closed circle. Less than or greater than is an open circle. All right, just make sure you remember that. And so now I'm going to use this one because it's less than or equal to, it's going to the left, right? Less than or equal to 3. See? All right. Again, on this one, guys, I showed you in class. No, that's not this one. This is not the one I was talking about. I apologize. So again, this was very similar to one we did before, right? Just got to solve for M. You have some distribution, do that and solve. So let's go back and look at this one. So let me rewrite this a little bit bigger. So we have M minus 7 is greater than minus 2 times M plus 0.5. Okay, so what is the solution set? Right? What is it? So you got to solve for M and then use the number line. Okay. So M minus, you're going to have M minus 7 is greater than, let's distribute now, minus 2M, 2 times 0.5 is 1. That gives me minus 1. So I'm going to add 2M here, 2M there. So now that goes away. I'm left with 3M minus 7 is greater than minus 1. I'm going to add a 7 here and a 7 there. So now that goes away. I'm left with 3M is greater than 6. And M is what? This means that M is greater than, divide both sides by 3, I get M is greater than 2. So remember now, this is a greater than, so I'm going to use an open circle. All right, so, and because it's greater than, it's an open circle, so I'm going to use this one. All right. Okay, it's greater than 2. So let's go back to the, where we at? Oh, here. So we're going to use this one, and it's greater than 2, right? Everything is greater than 2, right there. All right. Okay, let's move along. 13. Whew. Okay, again, this is it tells us a quadratic function. Quadratic function, and this is multiple choice. Okay, the function has what? Use a drop down. It has a maximum. By now, if you guys remember that, that's a maximum. And the value of the maximum occurs at what? Well, it's 4. See, this is a maximum and it occurs at 4. Well, I can't draw on that one. Let me go back to the slides. All right, graph. So remember, all right, this is a maximum. Remember, a maximum graph looks like this. All right, that's a maximum because that's the vertex, right? It's the highest point of the graph. And so remember, for these kind of graph, you're looking at minus x squared plus something, whatever. All right, the minus means that you have a maximum. If it's just x squared plus say 4x or whatever, x squared plus something, then you're gonna have a minimum. The graph looks like this, minimum right there. All right, just remember that. All right, okay, let's move on. What do we have next? Let's see. Let's see what we have next. Okay. Okay, what do you think this is, guys? Look at the equation. What are we talking about here? All right. That's exponential. All right. And I'll let you read it, but the population is measured in thousands. And so it's actually the initial population of bacteria, right, is what? What is the initial population? Well, it's going to be 575,000. So remember, let's go back and look at, guys, I've done this like several times in class. I want to make sure you guys understand this. All right? Remember, f of x equals a times b to the x. All right, that's exponential. Right, b, right, b is number b right here. B is usually b is usually 1 plus r or 1 minus r. Okay, that's why they have 1 plus 0.40. So when it's a plus, you know this is a growth, and r in this case, my r is 0.40. That is the rate. That is the rate. The factor is 1 plus the rate. All right. And so it tells you now this is in decimal, but if you make it a percentage and multiply by 100, it gives you 40%. All right. So that is the rate. Just make sure you understand that. And so if we go back and look at this now, okay, the population is increasing, right? Because why is it increasing, guys? Does it say? It doesn't tell you increasing, but if you look at the equation, let's go back again and look at it. All right, this number is bigger than 1.40. So B is greater than 1. That means you're increasing. Good. All right, let's move along. So it's increasing at a rate, and I just explained this, not 140, but 40%. All right. Done, almost there, 64. Ooh, I'm getting there. All right, here you're given a linear equation. It is in standard form, and I want to know which points are in the solution set. Okay, which points are in the solution set? Remember, I said before, all right, you want to solve for y, because I don't know if the solution set is above or below the line. Don't assume by looking at the equation like this. Well, I mean, I'm a little bit more experienced. I can tell where it's going to be at. All right. But I want you guys to get into the habit of solving for y first to see where your solution set is going to fall. So let's go back to my slides. All right. So remember, I want you to, so we have 4x. We have 4x plus 5y is less than 20. Again, always solve for y. Just don't assume, oh, well, it's less than, it's going to be below the line. In this case, it is, but I want to get in the habit. So we minus 4x, minus 4x, minus 4x. Oops, let's write this, minus 4x. So that gives me 5y is less than minus 4x plus 20. Divide by 5 on both sides, right? Divide by 5 on both sides. That gives me y is less than minus 4 over 5 plus 20 divided by 5 is 4. All right. So yes, it's below the line. In this case, it works. Same sign. So it's below it. So everything below the line. Also, if this was equal to right here, if this was equal, right, they would also include the line. But it does not, it's just below the line. So let's go back and look at this. So it's below the line, so it has to be these two right here. Good. All righty. Again, this should be pretty easy, guys. What are zeros? What are the zeros? You know, zeros are x-intercept. So it has to be these two right here. That's it. Okay. This is a straight up factor, right? Straight up factoring. You can use the box method. You can use quadratic. I mean, you can factor this. All right. Or let me see something. I'll graph it to see what x-intercepts are. All right. So in this case, don't want. Okay, let's look at this. That's not it. Okay. So let's do the box method. All right. So we have 2x squared minus 14x plus 24. Before I do the box method, I realized that 2 is a common factor between all three numbers. So if I factor out 2, it makes my life a little bit easier, right? So 2, that gives me x squared minus 7x plus 12. That is a lot easier to factor right here. That is a lot easier to factor. And if you do the box method, guys, you do the X box method. All right. Okay, so that's going to give me, put my x squared there, put my 12 there. And, you know, I'm factoring, remember, I factored the 2, right? The 2's to the side. Don't worry about the 2 right now. So I'm going to have is 12 on top and -7 at the bottom. And what two numbers? You know, when you multiply them, gives me a positive 12, but when I add them, gives me -7. That could be, so this is minus 3x, and this is minus 4x. And so, you know, this is going to be x here, that's your x there, that's going to be -4, and it's going to be -3. All right. So my factors now are x minus 4 and x minus 3. But don't forget this 2 right here. You put a 2 there. So that's it. All right. And so your answer now is going to be, so when I go, so for my answer, I'm going to put a 2 here, a 2, right? And then x minus 3 minus 4. That's it. And so that's it. Let's go to, so my answer, go back to this right here. So I'm going to have a 2 here. I think you got to drag it. And then minus 3 minus, and then 4. That's it. Okay. All right. Moving along. What do we have here? Okay. This, I know some of you guys forgot. I just know this one. Okay. Let's go back and review this real quick. Let's go back and look at this. All right. Straight lines. These are special linear equation lines. So let's look at this real quick. Quick review. So we have a graph that looks like this. Okay. This is my x, that's my y. And say this point is I don't know, say this is 5. Then we have another graph, it looks like this. Okay. Well, this time the line crosses the x-axis. Let's say this is, I don't know, 7. For this first graph right here, because the line is parallel and crosses the y-axis at 5, the equation is y equals 5, straight line. And the slope is always, for a line that's parallel, the slope is always 0, m equals 0. For this one, because the line is vertical and it crosses the x-axis, the equation is going to be x is equal to 7. But in this case, the slope is undefined. These are a special case. Make sure you know that. All right. And so for my answer now, just go back here. For my answer, all right, it's going to be y is equal to 2. A lot of kids put y equals 2x. And the slope is 0. So make sure you guys don't make a mistake. Okay, this is a pretty good one, pretty easy one, guys. Relation, is this a function? Well, you're gonna like, what does this graph look like? This graph, what does this equation look like? Well, just graph it and you see it's a straight line graph. Remember, all linear graphs, right? They're function, unless you have just, okay, I'm not going to go into that. Just our functions, all right? So that's a function. And then the table, it's not a function because the ones repeat, the x value repeats itself. So that's not. And then for this graph right here at the bottom, if you draw a vertical line, you'll see that it is a function, right? If I draw a line, it only crosses the graph once. So that is a function. All right. I think this would over. So there we go. Function. There you go. And then that's it. That's it. All right. I'm going to come back to this in a second, guys. All right. Oh, this is the number 20. All right. Is there 21? I'm going to come back to number 20 in a second. All right. Let's do 20. Yes. I know I've not answered it. Okay. Let's look at this one here. This is kind of not tricky, but you got to be careful on this one. Okay. So what are domain and range? Okay. Remember, this is a quadratic. Remember, it's a quadratic because the exponent is 2. So remember, for quadratic function, the domains are always what? Real numbers. So that's good right there. What is the range? All right. Now, if you're not sure what the range looks like, graph it, and you can see what the graph looks like. And so the graph's going to look something like this. Okay. I'm just going to give a rough sketch, guys. -9, -9, -8. I'm just going to give a rough. I'm not going to be really. All right. So on this one, if I graph it, right, looks something like, oops, oh, that went all over the place, huh? All right. If I graph it, all right, I think it was -9, minus something like this. All right, and so where the lowest point right here is -8. All right, -8. So the graph faces upwards and all the y values go that way. So y is greater than equal to -8. So that's my range. Okay, let's see. So we go back here, we do this, and we put range is, there you go. So that's number 21. All right. So make sure you understand that. All right. Number 20, guys, let's go back and look at this. Now, this is like it's kind of, I won't say a hard concept to understand. It's a new concept, and causation and association. All right. Causation is when there is a direct link between two items. All right. So for instance, look at the first one. It says that when the speed of a car decreases, the arrival time at a destination is also later. You get there later. Is that a true statement? Yeah, I think so. If you drive from here to, say, Sealy, and you drive, suppose you drive at 60 miles per hour, you can get there faster. But if you drive at 30 miles per hour, you're going to arrive there a lot later. So there's a direct link between those two. When the speed decreases, your arrival time decreases. Direct link. So that's causation. Now, what you got to remember now is this: when there's causation, there's also association. Right? So just remember that. If you have causation, you're going to have association. So just make sure you pick both. All right. Now, this one, you would think there's causation. When the temperature increases, the sale of snow cones also increases. You would think that's correct, right? Well, is there a direct link? Well, I'm going to look at it this way. I'm from Jamaica. It's very warm down there. All right, so it's 80 degrees in Jamaica all the time. If the temperature increases to 90 degrees, are there going to be more snow cones being sold? I don't think so. If it goes to 100 degrees, suppose it's very hot on there, it's not, the set of snow cones is not going to increase. So there's not a direct link between, you know, snow cone sale and temperature. Here in America, people tend to buy snow cones in the summer, but that's not direct link. So this one's a kind of hard concept. I would say neither on this one, neither. Okay, oven temperature now. Yes, if you increase temperature, the cooking time increases, right? Yeah, you're gonna increase the casserole. You may burn it, but it's gonna cook. All right, so there's a direct link between oven temperature increases and the cooking time is also gonna decrease. So yes, so that's causation. There's a direct link, but remember, if there's a causation, there's also association. So that's both. That's a little hard concept to understand. All right, just remember, we probably could talk about this on Monday. And then what's the next one? I did 21. And oh, that's it. No, 22. I think it's the last one. All right. This is not a transformation again. And let's go back and let's look at this one in depth. Okay, next slide. Next slide. Oops, that's not what I meant to do. So here we go. All right, so we have a function f of x, and the new function is 3/4 f of x plus 4. All right, so that's a transformation, right? So we have f of x, that's the original function, and it got transformed to, got transformed to 3/4 f of x plus 4. All right. So if we write this out, we can simplify this. Before I do that, let's look at this. Well, do I want to do that first? Okay, it asks you, is the graph of f steeper than g? Well, let's look at the new equation, right? We're going to have 3/4, right, times x plus 4. And if I multiply through, so that's my new function g of x. If I distribute now, I'm going to have come on, 3/4 of x, right? And what is 3/4 times 4? That is just 3. Okay. So if you graph this equation here and this equation, you'll notice, right, that f of x has a steeper slope. You can graph them. I'm not going to graph it for you guys. Graph both of them, and you will see that this function has a steeper slope. All right. So f is steeper than g. And then to create g, f is translated 4 units to the left. Is that correct? All right, we have x plus 4. That's a new function, x plus 4. What does x plus 4 tells you? Remember, the plus 4 tells you that the graph shifts to the left. So yes, g is created by translating f 4 units to the left. So that's correct. And then the x-intercept, again, you can graph it and you'll see that, in fact, let's graph it then. We have what? X and 2 for x plus 3. I'm going to graph this one. All right, so let's home, new, no save, graphs. And so we have the first graph is y equals x, right? I'm just going to put, we don't put the y equals, we just put x, and then we put enter. So that's the graph. My second graph now is going to be tab. Where's my tab button? I'm going to enter 3/4 x plus, was it 3? Can't remember now. Yeah, 3/4 x plus 3. So now we're going to have 3 divided by 4 x plus 3. Okay, hit enter. Now you see now, right? You see that the blue line has a steeper slope. All right. And then the x-intercept for the red line for the g function is 1, 2, 3, 4. So what was the question again? I don't remember. Sometimes you have to graph it to really see. And so the x-intercept of g is, yes, is 4 units to the left of f. Yes. So that one's correct. And then we say was steeper. And the other one, could g, yes. So that's it right there, guys. And I think that's it, guys. Give me a second. I think that's it. Let me. All right, guys. Hey, I went ahead and submit my my results, and as you can see, I think I just missed one. All right, and you can see it is number 20, and that's the one with causation and I think that's the one, causation and is it? Yep, I figured that's the one. I missed one of those points, and I think both. I think this should have been association. Yeah, I'll go back and look at it one. But okay, and so we'll talk more about number 20 in class on Monday. All right, but overall, not bad. I mean, I missed one on it. All right. So again, just again, you can do this as many times as you want, guys. As many times as you want. Make sure you understand how to move the graphs and stuff like that. All right. And hopefully this video helps you. And good luck. All right.